Hi, and welcome back to the channel. And today we're going to take a look at my Apple IIe. Now, the reason for this is that about a year ago, I released a short series, 3 videos on the Apple II in general, going from its inception in 1977 to its eventual demise in, I think it was 1995, with the Apple IIe card eventually being removed from the market. This machine has had a massive impact on the world of microcomputing from its release back in 1977. And in that series, it was a relatively high-level view of the entire series of machines. Originally, it was released with the original Apple II back in '77. Then a couple of years later, I think it was in '79, they released the Apple II Plus, which had some improvements in it. And then by 1983, the Apple IIe was released. Later on, Apple went on to release the Apple IIc, which was a small form factor version of the machine. There were other enhancements. There was the Apple IIe Platinum, and I believe there was also an Apple IIc Evolution as well. So during that series, I had a number of people ask me, why don't I actually show the machines? Because in that video, I showed them relatively remotely, and what I wanted to do was actually, as it were, get in there and actually show you exactly not so much how this machine works, but exactly what it has to offer for somebody. Obviously, it's not really a workable machine today, although interestingly, I did see a post on Reddit earlier about an Apple IIe actually seen out in the wild today, still being used. I think it was being used to control a security gate or something like that, which is obviously quite a lowly task for this really cool machine. But it's interesting that even today, in 2025, an Apple II was actually seen out in the wild, still doing work. So that gives you an idea just how sort of durable and long-lasting and practical these machines are. So what I want to do is invite you in to come a little closer. We're going to take a look at this machine. We're going to have a look at the outside of the case and then the inside. And then I'm going to show you some of the interesting features and expansions that we have for it. But before we do that, let's have a quick word from our sponsor, PCBWay. PCBWay, where you can make your tech dreams a reality. And now in PCBWay's Project Share, you can upload your projects and share them with the community. And if you do use any of these projects, a percentage of the money that you pay will actually go to the author. So you can share your projects and you can also benefit the projects that others have shared on PCBWay. So if you do have any projects, why not upload them to PCBWay and get them out to the community? And of course, why don't you browse the Project Share and see if there's something there that's interesting for you? Because whether it's PCB prototyping, PCB assembly, 3D printing, or even CNC machining, PCBWay is the way. Starting with an instant quote for your PCB projects, PCBWay will leap into action, building your PCB, assembling it for you if you wish, and once it's passed their quality tests, it'll be winging its way to you in a flash. PCBWay, PCB prototyping the easy way. So the first thing we can say about the machine is it has a relatively large case. It's made out of actually quite a thick plastic. When I first got it, I actually thought it was metal, but it is actually just plastic. It's actually grey. When I show you underneath this hatch later, you'll see that the paint, which is actually sprayed on, is starting to chip off, which is perfectly understandable based on the machine's age. It's getting on now. There you have a metal badge, actually 2 metal badges. You've got the original Apple II logo, which again, has seen better days on my machine. Maybe I can get a replacement for this at some point. And then here you've got the Apple IIe badge, so you can tell that this is an Apple IIe from 1983. I would say, although it is quite large, let me just show you how large it is. I'm going to show you a Commodore 64 perched on top of it. So there you go. You can see, it's a pretty large machine. However, where I've actually placed that Commodore 64 demonstrates that in fact it has enough space on it to actually fit a television on top of it. And in fact, back in the day, this was a very common practice. I know that Apple asked people not to do this because of the heat, going from the television, and it would tend to block the ventilation here. But to be fair, most people actually did do that. There are even photographs of Steve Wozniak, the engineer who made this machine, actually doing that as well. So yeah, it was a little bit hypocritical, but it looks like it didn't actually cause any real damage to the machine. You can see it's actually an attractive machine. I would say it looks pretty friendly. The outside of the case is pretty plain, which means it has a pretty simplistic appearance. I would say the color scheme, which is very typical for the time, beige was very much hot industrial color, gives it a pretty basic but simple appearance. I think it's an attractive machine, certainly. It's attractive as the Commodore 64. If you look at it compared to its original competitors, the TRS-80 and the Commodore PET, the TRS-80 has quite a nice design actually, but I think the Commodore PET is definitely a lot more sort of industrial and angular looking and definitely gives off sort of boffin vibes. This looks like a machine that could be used by the average person. If we take a look on the back, we will see on the left-hand side, you have an RF connector. So one of the aims that Steve Wozniak had when he made this machine was that he wanted it to be connectable to a standard security monitor, I think was the idea. They were relatively cheap, not saying they were cheap, but they were relatively cheap. They had pretty good image quality, and that required an RF connection. Now, one of the other things that you could do with this machine was you could connect it to a standard television, but that required an RF modulator to then convert that into the signal type that a TV required. And that was an external module that you would buy for your machine. So next to the RF output, you have two audio inputs. And you can see there, you've got little icons that indicate they are to do with the tape input and output system. This machine, when it was released, it didn't have a disk drive. And originally software was intended to be loaded from cassette. This was a very standard thing back in the 1970s and 80s, and it was a way of saving money. So let me just show you an audio cassette. I have one here from the late 80s. And this was actually given to me by a friend of mine. It's actually a mixtape. It's got some late 80s music on there. So this is an audio tape, and this is basically what the software for the Apple II would have originally come on. It's a cheap solution. The tapes themselves can actually store quite a lot of data, but the problem is that the tapes can stretch. The tape recorders themselves can be of variable quality, and that meant that it was generally a relatively slow and unreliable way of loading and saving software. But as I said, in the original design of the Apple II, it was a tape deck or nothing. So you have a port for sending sound into the computer, and you have another port to send sound from the computer to the tape deck. So obviously if you're pressing play, the sound would go into the computer, a series of sort of screeching noises that contained the binary data. And then when you wanted to record, say, a basic program onto tape, you would press record on your tape recorder, and then the sound would come out of the output there, and that would then record onto the tape. I actually used one of these tape decks with my Commodore 64, and I was very, very happy once I eventually managed to get hold of a disk drive, because life became much easier at that point. To the right of those two ports, you then have a joystick port. It is a DE9 connector. In this case, it is a female connector, which is quite different to the Commodore 64, where it is a male connector. I believe the male connector was more of a standard, and that came from the early Atari console, the Atari 2600, or VCS as it was called. There is something else which is slightly different about this machine as well, in that the joystick in this case is analog, which is unusual. Generally, computers had digital joysticks. So let me just show you a joystick. So this is an example of an analog joystick. I actually waited to get this particular model of this joystick. It's actually a relatively modern one, very good quality actually. And I tried to get this particular model because it's designed with the colors in mind for the Apple IIe, not the Apple IIe Platinum, which was a later model. You can get this basically in a kind of gray color, which is what the color scheme was of the Apple IIe Platinum. So there you have the joystick. As you can see, it's relatively loose. And what's nice about it is that you have this analog capability. So obviously the more you push, the more your character in a game moves around. Not so good for twitchy games, but for flight simulators and various other games, it was fantastic. And I wish we had this option on the Commodore 64. It would have made a lot of games a lot more fun to play and a lot more controllable. So yeah, a bit of a plus there for the Apple II. Now on the far end of the machine, you can see we have an IEC power connector. That's a pretty standard power supply plug for, well, pretty much everything. I think the Amiga 2000 had one of these. Typically PCs these days will have them, so that's a very standard thing. And then to the right of it, you've got a power switch to obviously turn the machine on and off. And the position of the power input there and the switch can give you an idea of where the power supply is inside the machine. If we go back to our Commodore 64, let me just show you this. What's a little bit unusual, I think, about the Apple II is the lack of expansion ports on the back of the machine, or at least by default. You can see here on the back of the Commodore 64, we have a video out, we have a serial port. You'll notice that there isn't a serial port on the Apple II. We have a cassette port, which, you know, to be fair, is the same as the audio in and audio out for the Apple II. But here we have a user port, which is a general purpose port. And over here we have a memory expansion port. So the Commodore 64 has opted for a more all-in-one. And this was something that Steve Jobs was aspiring towards. And we'll talk about that a little bit later. So where are these on the Apple II? Well, the answer is they are not actually standard. The machine by default doesn't actually have a serial port. It doesn't have a parallel port. Indeed, it doesn't have a port to connect a disk drive. If a disk drive were to be invented for it, you wouldn't be able to actually plug it into anything. So the way that Apple got around this was they actually, well, it wasn't a compromise, let's put it that way. They went the other direction. They gave the machine more expansion, way more expansion capability than the Commodore 64. And the way they did this was by adding a number of slots. So let me just show those to you. So you access the slots by going through the top of the machine. And there are normally 2 screws here that hold the back on. Generally, Apple II users never put those screws in. You take them out when you receive the machine and you probably never put them back in again. They use pretty standard sized screws, so you can actually put them back in if you're shipping it, for example. But yeah, apart from when you're shipping it and receiving it, you probably never put those back in again. There's a couple of like Velcro-like tabs here on the back, which actually hold it in place when it's actually put down. And you can see here you've got some RF shielding as well. You can see here that the paint is actually starting to chip away inside the case. But luckily I haven't had any major pieces of it actually flake away from the outside. If that did happen, I would then try and strip off this paint and then respray the case, obviously covering up these nice badges here. So inside you have these slots. And you can see, let me just hold this up to the camera a bit better. And you can see that you have 1, 2, 3, 4, 5, 6, 7 slots. And you also have another slot here. So the original Apple II had 8 slots. This still effectively has 8 slots. But this slot was originally here and it was called slot 0. By the time you get to the Apple IIe, you have slots 1 through to 7. And then you have this, which is called the auxiliary slot. Now these slots, these are what I would probably say the key feature of the Apple II line of computers, which in a way makes the Apple IIc an oddity because the Apple IIc is the only one of this range which doesn't actually have these slots in it. The Apple IIc was designed though as being a sort of portable device. It even has a carrier handle, so you can understand the direction that Apple were going in with that machine. But it is, I would say, definitely the defining factor of the Apple II in the same way as we see in modern PCs. Now, I've heard that when the Apple II was being designed, there was quite a disagreement between Steve Wozniak, its principal engineer, and Steve Jobs as to its ports and its expandability. Steve Jobs, he wanted a sleek appliance-like machine, as I said, something like the Commodore 64, something that could be plugged in and could be used immediately, something that wasn't intimidating to the end user. However, Steve Wozniak, he had grown up in Silicon Valley, learning electronics in a local community where hackers, the children of other engineers who worked in Silicon Valley, interacted with him. Those hackers, they like to take electronics and they like to adapt them in various ways. It's not always nefarious. The term hacker these days has a different meaning from what it meant back in the 1970s. Back then, it was to do with adapting a piece of electronics to do different things. Wozniak, he was committed to the hacker ethic. He had grown up with it. And what he wanted was a computer that would be configurable to the 9th degree by its users. And it appears that Wozniak was possibly influenced, I would imagine, by the S100 bus, which is featured in the Altair 8080. This was an earlier micro, and a micro that was based much more, I would say, on a mini computer, at least in use, because for that you needed a terminal. And one of the goals that Steve Jobs and Wozniak set out was that the Apple II wouldn't be like that. It would be as much as possible an all-in-one. So they didn't, in the end, build in a monitor, but they did build in a keyboard. And in the original Apple I, there wasn't actually a keyboard. You had to supply that yourself. And this would have been the same state of affairs with an Altair 8080. You actually had to add one of those yourself. But the 8080 did have this amazing S100 bus, which allowed you to go into the machine and change it to do what you wanted. It didn't necessarily come with a lot of features, but by adding in these cards, you could turn the machine into a much more capable machine, almost as expandable as a mini computer, though with less memory, etc., etc. So you can see how a bus like this, with numerous slots to access, how this fitted into Wozniak's vision and how that didn't fit into Jobs' vision. So in the end, Wozniak's view won out, and this very much defined the Apple II experience, as you can see in front of you here. The Apple II, it was a machine that handed control to the user. It said, come on, have a go at making me better in a way that you want. Its slot-based design was also a very smart decision because it massively extended the life of the Apple II, because its slots made it so expandable. And very quickly, an industry grew up around the Apple II, making many different types of expansion cards for it. So here we are inside the Apple IIe. And as I said earlier, we have these 7 slots here, which are for standard expansion cards. And then you have an auxiliary slot here, which is for very specific cards. And because of that, it has specialized signals in it. It's actually had contact to the main bus of the machine removed, and only certain signals remain. But that means it is suitable for extending the memory of the machine and also for modifying the video output of the machine as well. And for this reason, this slot was pretty much always used with an 80-column card. The 80-column card allowed the physical display of text on the screen to double in width, and that meant that the text became smaller and more dense and basically more easy to use. This was pretty much a standard on terminals, and on microcomputers it tended to not be a standard, so this was something of a business requirement for the machine. When the machine was launched, it didn't have the ability to do lowercase text or 80-column text. Those features came later, but this machine already has the ability with the 80-column card to have 80-column text. That card also came with more memory on it. These slots were originally designed to be relatively homogeneous. And what I mean by that is that ideally cards could be plugged into any slot and they would work in that slot perfectly fine. That didn't necessarily turn out to be the way it was in the end. For example, slot 7 here, that has specific video signals which go into it. The other slots do not have it, and there's a good reason for that. It's because if those video signals travel through all of the other slots, the amount of noise that would be introduced into that signal would cause the image of the machine to degrade. So a decision was made to put those signals only into slot 7. And it's for this reason that you tend to find that video cards are only viable in that slot. Another slot that's got a certain amount of significance is slot 6. And the reason for that is that a little bit later in its initial life, a disk drive system was actually released for it, and an expansion card was released. And I think what happened was it was shown plugged into slot 6 in the manual, and everybody followed along with that, and that then became a de facto standard, to the extent that certain software developers actually wrote their software so that they expected slot 6 to be used for the disk drive, and if it wasn't used, then the software would not load. So that obviously became a little bit of a problem. Not a massive one, but it's something you need to be aware of when you're kitting out your Apple II. Another card that was very popular, especially in the early days, was what was called a language card. And these language cards basically had ROMs on them, and you could plug the card into generally slot 0 and slot 1. This machine doesn't have a slot 0, it only has a slot 1. So I would imagine on the Apple IIe, you would plug it into slot 1 here. And those cards replaced the programming language. So for example, if you wanted to use Pascal and you wanted that to be available for you as soon as you turn the machine on, you would get a Pascal language card, plug it in here, turn the machine on, and voila, you've got Pascal on tap to do some coding in. So yeah, that's what the language card was for. So an interesting expansion there. What else do we have in this machine? Well, you've got the CPU here. Originally, that would have been a 6502. It isn't in this machine, and we'll talk about that a little bit later. Then you've got a ROM. It's called a CD-ROM. A little bit confusing because in the 1990s, we got the CD drives and they were called CD-ROMs because the data came on disks that were not readable. In other words, read-only memory. And this is a ROM, but the CD in this case refers to the area of memory that this ROM maps to. So it's actually something like CD 100 to DFFF in hexadecimal. So that's why you've got that name. It's a little bit confusing, but that's where that comes from. The EF-ROM is the same thing. It maps to an area of memory around E going to F. And I believe each ROM is only half of the entire firmware for the machine. So in combination, the two of them together basically give you all of the sort of core logic, which is, as I said, defined as a firmware. So you can upgrade it, which is quite a cool feature that you can actually upgrade the machine. Then you have the video ROM, again, upgradable, and that actually has the software in it that defines the display modes for the Apple IIe. That was one of the key features of the machine, the ability to have color graphics. So one of the big selling features for the machine when it was first launched. And then over here, you've got another ROM, which is a keyboard ROM right next to the keyboard connector. So this keyboard here, nice keyboard, you know, pretty decent to type on once you get used to the layout. That then plugs into this connector here. We also have a speaker, which is underneath the keyboard here, facing downwards. The machine has very basic sound. It only has one voice, and it doesn't actually have really a sort of sound chip, not really. So the sound is generally produced by the CPU. Then we have here the power supply, which is a really nicely designed, high quality switch mode power supply. So as you can see, relatively simple machine inside. A lot more complicated than, for example, the Commodore 64. Originally, this logic board was a lot bigger and it had a lot more chips on it. And that was because pretty much everything in the machine was actually implemented with discrete logic. So this machine, as I said, was simpler. It was simpler in that it didn't have as many chips as the original machine. That meant that it was easier to produce, cheaper to produce, but for the end user, it actually was more reliable as well. So that was a good thing. If you're a hacker and you're being a purist about it in the way, you know, Wozniak would have originally liked it, one of the other things about that original machine design was that you could actually place any chip in the machine yourself. Every single chip that was in it originally, apart from these, you know, custom ones, the ROMs and things like that, everything would have been available off a shelf and you could have rebuilt the machine from scratch if you really wanted to or needed to. So by the time you get to the IIe, not so possible because you have got these custom chips here where some of the logic has actually been integrated into those. And yeah, that's just the way progress has tended to go over the years. Now, why does this machine have these labels on here? That's actually not a standard thing in an Apple IIe. The reason for that is that these are not the original ROMs that were in this machine. So around, I think it was 1985 or so, Apple released what was called the Apple IIe Enhanced Kit. And the reason for this is that in 1984, they released a new model of computer, the Apple IIc. And the Apple IIc was intended to be a more mobile version of the machine, had a carrier handle, as I said earlier, and it did actually have a number of enhancements in it. One of the things it had was a different CPU. It had a 65C02. That was put into the machine, I believe, because it was very, very cool compared to the original chip. It used a lot less power. I think it uses like a 20th of the power, which is kind of crazy. So you can imagine that chip produces a lot less heat. And when you have a very confined case, that's a big plus to have. On top of that, that chip has a lot of enhancements. I think it has 27 new commands. It has bug fixes. So it was a bit of an enhancement over the original 6502. And because of that, some software was actually released for the IIc, and that software could not actually run on the IIe because it didn't have those extra commands. So that presented a little bit of a problem. There were other features as well. So for instance, the IIc had a thing called mouse text, and that was a set of basically characters, text characters, and they could be combined together to create a complex GUI for more modern software. Something more akin to what you would see on an Apple Mac or in an Amiga or something like that. So these features were desired by Apple IIe users, and as a result of that, Apple offered an upgrade kit to upgrade Apple IIes to the same kind of spec as an Apple IIc. And that's what I actually have in this machine. This is not a 6502 anymore, it's a 65C02, the new processor. This is a new ROM for the firmware, and it also has a new video ROM. So you actually have the extra features of the Apple IIc. So let's talk a little bit more about what we have inside the machine. As I said earlier, in this machine we have the 6502. This particular machine has a 65C02, a minor upgrade. But in fact, both chips run at 1.023 megahertz. And the 6502 was a really common chip back in the 1970s and 80s in microcomputers of that era. It was created by a guy called Chuck Peddle. Unfortunately, he's passed away now. And Chuck created it as a response to the much more expensive Motorola 68000. This chip was actually produced by Motorola, and Chuck actually worked there at the time. And he was dissatisfied by how much take-up that chip had out there in the greater community. And he had a vision that if he could create a cost-reduced version of that chip, then that microchip could go out to many more people, and it would get adopted into the industry and possibly even spawn a new industry of microcomputers. And so Chuck left Motorola, ended up working at MOS Technology, who liked his idea, and eventually they worked together to produce the 6502, which, as I said, was an extremely popular chip back in the 1970s. It was in the Atari 800 and in many other machines of that era. And it also, for instance, featured in the Commodore 64, although there it was in a slightly different format. I believe it was the 6510 chip, which is a sort of updated version of that chip. Now, although the 6502 is a powerful microprocessor, the Apple II does have a bit of a downside to it, which is it does rely on that processor to do basically pretty much everything. And I would say the Apple II, along with its slots, is very much defined to a large degree again by its video and sound capabilities. And they are pretty limited when you compare them to, for example, the 8-bit Atari computers and also the Commodore 64 that we saw just now. You can imagine that both Atari and Commodore, when they were designing their own computers, pored over the specification of the Apple II and then aimed to remove any of these limitations. And that's why those machines had specifically engineered sound chips and graphics chips that were in advance of what you have here in the Apple II. That isn't to say that it's a crude machine. It does have color graphics, which are very much defined it against its competitors. Both the PET and the TRS-80 only had black and white graphics, so it does actually have color graphics. However, they are implemented in a certain way that makes them a little bit problematic, and we've been over that in other videos. You have color bleeding between pixels, and that's something that's difficult to get away from with the Apple II. The sound is only a single channel, and that sound is basically implemented by the CPU. And as a result of that, there are two things that can be said. Number one, the sound is very limited, and it's also taxing on the CPU because the CPU has to basically do everything. A plus side, though, is that tricks were found later, which allowed the Apple II to actually produce more than one channel of sound. But to do that, the CPU had to get involved in a pretty big way, doing all of the work with the sound. And that meant that you really couldn't have that much going on when you had more sophisticated music playing on the machine. Also in video games, there were no sprites. The machine didn't handle sprites, basically little bitmaps that could be moved around the screen independent of the rest of the graphics. That wasn't a feature, something which was added in the Atari 8-bit machines and also in the Commodore 64. You can imagine that would have been a major feature for Atari to get done because they came from an arcade background. I suppose they had to choose limitations somewhere, and that's one of the limitations of the machine. It also doesn't support hardware scrolling. So when you play certain games, the machine is basically juggling a lot of different things, and because of that, it can actually bog down. And that's one of the defining factors of this machine. So we've learned quite a lot in this video, haven't we? This machine was created in 1977. As we spoke about earlier, Steve Wozniak, just a couple of years earlier, was at the Homebrew Computer Club in California, and he saw the Altair, and that created a spark that eventually led to the Apple I, and then just a very short time later, just 1 year later, the Apple II was produced in what I must say is just an amazing feat of engineering. You know, for such a young guy to produce a very complex machine like this in just a single year is crazy, really. And what was very interesting was that dynamic between Steve Jobs and Steve Wozniak. You know, Jobs had, I think, the right intention that he wanted to create a machine that could be used by anyone, you know, built-in keyboard, maybe even a built-in monitor, just a device that you could just put on your desk and start working on it. But Wozniak, he wanted a machine that you could hack and change and, you know, put cards in and, you know, so you could turn it into the sort of like his own dream machine, if you can think about it like that. And his vision was that there were many other people out there like him in the US who would want to do the same thing, had the money and the inclination to get a machine like this and pop cards like this into it and turn it into the machine that they wanted to have. So originally I planned to show some of these cards that we have here on the table in this video, but it's already about half an hour long, so I'd like to maybe do that in a second video. That would give it more space to breathe in and we could talk about these cards with a little bit more detail, which I'm sure you'd like to have. What I will do very quickly is just go through some of them. So just to whet your interest and to show you what we're going to look at in the next video. I think it's going to be very cool. In my hand, I've got one of those Disk 2 interface cards. So after a very short period of time, Wozniak must have realized that the tape drive was not the way to go with the Apple II. He wanted something more professional. He had actually worked at Hewlett-Packard in the office in California. So I assume that he saw hard drives and he saw disk drives. And I would imagine at that point, a hard drive wasn't really on his radar, but a disk drive definitely was. So very quickly, he engineered the Disk 2 system. And it consists of this card and this drive here. These are some floppy disks that we'll be using in the next video to work with this drive. So this is the actual Disk 2 drive, and it's a bit of an icon of computing if you're an Apple II fan. A very, very cost-effective device, surprisingly performant as well, especially if you compare it to the Commodore 64. I've been doing that throughout this video. It's good to have something to compare against. What's interesting is the Commodore 64 came out a number of years after the Apple II, and the disk drive then took a while to engineer. And it was very slow compared to the drive that Wozniak managed to put together. Wozniak kept it simple, and because of that, you just needed one of these, which would plug into the machine, and off you would go. You could actually start getting into the world of disk software, and that really revolutionized, really, the use of the Apple II. A little bit later in the life of the Apple II, that system was kind of updated and to some extent replaced by this, which is, it doesn't really have a name, but it's a series of drives that work with this. So this is the replacement for this card, and it goes into the back of the machine. So you actually have a proper, what is it, DB25 or something like that, jack, which is quite important because there were certain issues with this design that caused quite a lot of hardware failures. So this would go into a slot in the machine, and the drive that goes along with this is this one that you can see here. This time it has an actual cable, and you can plug this into that card once it's plugged into the machine. And what's quite nice about this one as well is that you can actually daisy chain it. So on the back here, you've got another port, so you can plug in another one of these. I'm not sure how many you can do. I think you can do 4, but yeah, that's something we'll look at in the next video. We'll put this card out of the way. Another thing we're going to look at is some of the modern cards. Now, not all the cards here that you see are actually from back in the day. Some of these are actually modern creations. And I think that's one of the really cool things about the Apple II scene. It's a little bit like the Amiga scene, where people are now making brand new devices for the Amiga that can plug into the big box Amigas and the desktop Amigas. You've got exactly the same thing going on in the Apple II scenes. It's pretty vibrant, actually. It's really interesting. This is a VID HD card. This will actually get the machine working with a HDMI monitor, which is, to be honest, a bit of a must today. You can obviously use it with a real legacy monitor, the kind of thing that Wozniak would have used back in the day. But the truth of the matter is they're getting rarer, are much harder to find and work with. They tend to break a lot, and they're not the kind of thing that most people can repair, to be honest. So that's an interesting little card. What else have we got here? I mentioned it earlier, the 80 column card. That's something I have in my machine. And the reason for that is if you want to use 80 columns for whatever software, some software supports it and will actually kick the machine into 80 column mode. And if you're just doing, let's say, for instance, basic programming, it can be quite nice to be in 80 column mode as well. And the other thing which is really important about this card is it has another 64K of RAM on here. So when this is plugged into the auxiliary slot, this machine is actually bumped up to 128K, which is really cool. I mean, for a machine from 1983, that's really, really nice. The Commodore 64 would wait a couple of years until it had the Commodore 128 to get up to that amount of RAM. But it's interesting that with the Apple II, you can just basically engineer your way into that kind of expansion. You don't need a new machine just to have more RAM. You can just put a card in and get more RAM. And I think eventually these expansion cards could even get this machine up to about 1 meg of memory, which is kind of crazy. I think that's a possibility. What else have we got here? Going back to I/O, the Booty, another modern device. This is very interesting. It uses USB sticks. You put that in there and you plug it in the machine, and that allows you to boot up off here very, very quickly into basically what are sort of hard drives. We'll talk about that in the next video. A very interesting device and very practical and easy to use. And I think they're quite cheap as well, about £75. So definitely something to be on your radar. Oh yeah, this is an actual original from back in the day, and this is a serial card. And the reason why you would want to use one of these is because you could actually write software to floppy disks on this machine without actually having 2 floppy disks. So that's always a bit of a sort of catch-22 situation. You want to use the machine, you only have 1 floppy drive, but you want to copy software onto the floppy disk, but you can't because you haven't got another floppy drive. So, you need 2 drives. So in other words, with this disk 2 card here, you could have 2 drives because it does actually support 2 drives. But you'd obviously have to buy 2 drives and keep them working and so on. Well, it turns out that back in the day, there was a piece of software which would actually connect to the machine through a serial port. And that's why I bought this, to try that out. And it's really cool, actually. What you can then do is you can actually control the machine from another machine. And in this case, it's actually a modern PC that you use to control the Apple II. And you can write disk images directly onto floppy disks using this card. It's also configurable, so there's lots of dip switches. You can actually decide that it's going to be used as a printer connector, or you can use it to connect to a modem if you want to do that. So another interesting card from back in the day, and these are relatively affordable. They were pretty ubiquitous, and you can get these for a reasonable price these days. And we'll finish off with another card here. This one is another modern creation. I don't think you can actually buy these anymore. And I must admit, I've had a bit of a problem with this card. It's a SCSI card, which is pretty amazing, really, because SCSI was a sort of high-end hard disk solution, and you could also connect CD-ROM drives, tape drives, printers as well. And you could have up to 7 devices all attached to the one card. A really popular I/O solution back in the 1980s and 90s, but very much a high-end device. This is actually a clone of an Apple II SCSI card. As you can see, well, I don't know if you can see that there says A2, Apple II SCSI. And the reason why it's been problematic is I bought it actually to use in my Apple II GS, which is a slightly more modern machine where, having large amounts of storage would be more appropriate. But I just couldn't get this thing working. A problem with the drivers, and I've reached out to GG Labs on the website, sent them various emails for tech support, and I've had literally nothing. So pretty disappointing, really. But I must admit, what I haven't actually tried up until now is using it with the Apple II. It will actually fit in there. It is compatible, and it does say that it is usable with an Apple II. So I may try it with the Apple II and see what that involves if I need to install drivers on the Apple II. Don't really know how that would work, because we'll talk about the way the Apple II operates in the next video. But yeah, let's try and do this as a stretch goal in that video. Let's try and get this thing at least working in the sense that I can actually boot off it. It would be great if I can actually get it to work in the way that it's meant to work, where I can have, multiple hard disks. Just turn the machine on and, you've got multiple hard disks. Earlier, I showed you the desktop software. That would be interesting, wouldn't it? Can we get the SCSI device working with that desktop software so that we turn on the machine and a few seconds later, we're in that desktop software? So lots of possibilities for the next video. I think it's going to be very, very cool. It's going to come out pretty soon. I'm going to try and get it out to you as quickly as I can. And for you to see it, please make sure that you subscribe to the channel. And even if you are subscribed, make sure you hit the bell, because if you don't hit the bell, you won't get notified about that video. And I really would like to see you come back and see the second half of this little mini series when it's ready. Like I said, it's going to be pretty soon. So yeah, hopefully you can come back and see that. If you enjoyed the series so far, please click on the like button, give the video a thumbs up, give it a poke, that like button, because I really want this video to get out to other people. Anyway, I hope you've enjoyed it. And I hope to see you in the second video, which, as I said, is going to be pretty soon. So until then, take care and have a good day.